we are now going to cover shortcuts in long division. I must confess, a lot of you will not like this section, but it's a really good section if you can understand what I'm saying. Now, one of the things we're going to use big time is the fact that we are experts in dividing by 1. Why are we experts? We don't have to do it. The answer is just 8. How much is 13 divided by 1? Oh, we're dividing by 1, don't do it. Here's my answer. It's 13. We're really good with dividing by 1. What is 27 divided by 1? It's just 27. After all, 27 divided by 1. Just ask yourself, 1 times what gives you 27? Well, 1 times 27 gives you back 27. Okay, so what we want to try to do is get our long division problems to become division by 1. If somebody asks you, what is 7,500 divided by 10? Well, whether you write this step or not, you should realize that if you see no decimal, it's all the way to the right. Okay, then you have a rule that says you can move the decimals as many places as you want. 7 to the left, 4 to the right, 1 to the left, 17 to the right, as long as you do it to the top and the bottom. Oh, I would love to move that decimal on the bottom 1 place to the left, because then I'm going to get 1.0. But 1.0 is the number 1, after all. The 1 place, they both have a 1 in it. This is called the tens place. We didn't talk about that yet. But it has 0 tenths. So does this. It doesn't say that it has any tenths. It just talks about the 1th place, which happens to have a 1. They're the same number. They're the same number. $1 is the same as $1.00. They're the same. They're the same. You go into a supermarket and you see this sign, or you see that sign. Well, we know what the dollar means, but we'll still say this is $1. Why? Because that's 1. We'd also call this $1 because that's 1. That, of course, is the dollar symbol. But this is 1. No tenths of a dollar, that is, no dimes, and no pennies, no hundredths of a dollar. They're equal. So you move the decimal on the top 1 place to the left. And the top will be 750.0, and the bottom is 1.0. But 1.0 is 1, and you don't need that other number. That is, we're dividing by 1. Of course, you were taught that you can also just cross off 1 0 from the top and the bottom. And there's your answer. I did it a very, very long way. We'll start doing it a bit quicker. If you can get the problem to have a 1 in the denominator, you really accomplished a lot. If you were to do 8, 4, 3, 2, 1, and you want to divide this by 100, you do not bother to do this. And if you did, you should say, oh, I'm going to move this decimal 2 places and this decimal 2 places. That is, move the decimals 2 places. If you don't see a decimal, it's understood to be all the way to the right. And then you have 8, 4, 3, 2, 1 divided by 1.00, which is 1. Oh, I know how to divide by 1. I'm an expert in dividing by 1. Don't do it that way. Get out of that. You have 8534.1243. You want to divide this by 1,000. Well, in the bottom, I don't see a decimal. So the decimal is understood to be there. Move it 1, 2, 3 places to the left. Now I'm dividing by 1. Oh, don't even do that. But if I move the decimal in the bottom 3 places, I have to move the decimal in the top 3 places. And there's my answer. 8.534123 divided by 1. But the rule for dividing by 1 is I move the decimal, so that number in the bottom is now 1. The rule for dividing by 1 is don't do it. Don't do it. Okay, I'll erase it. I won't do it. And I get the right answer. If you can get a 1 or if you can get the bottom to be 1 or 10 or 100 or 1,000 or 10,000, you can easily get it to be a 1. In fact, this leads us to this problem. You can divide that top number by 25, a 2-digit number. You can actually do 25 into 1243. 25 times 4 is 100. When you subtract, you get 24. Bring down to 3. And 25 into that goes 9 times. That's 225. If you were to subtract, I guess you'll get 18. So you have 18 over 25, which happens to be 49.72. A much, much easier way of doing this is you can take any number in the world and say it equals itself times 1. If I write 1 in there, well, 1243 over 25, this number, times 1, will certainly equal 1243 over 25. The way I'm going to write 1 is 4 over 4. Why? Because 25 times 4 is 100. And then I just move the decimal 2 places in. That should be not hard. That is, instead of dividing by 25, I'm multiplying by 4. Instead of dividing by a 2-digit number, I'm multiplying by a single-digit number. And multiplication is always easier than division. 16 and 1 is 17. 4 times 2 is 8, plus 1 is 9. 4 times 1 is 4. So all I did was I multiplied the top number by 4 rather than dividing it by 25. And then I moved the decimal in 2 places. And there's my answer, 49.72, which is the same as 49 and 18 over 25. We'll learn how to convert 18 over 25 to a decimal. What I'm getting at is, if you can get what you're dividing by to be 100 or 1,000 or 10, go for it. All I did was multiply the top number by 4. That's all I did. That's all I did. I multiplied by 4, and I moved the decimal 2 places. Rather than doing long division by 25, a 2-digit number, I multiplied by a single-digit number. There's not a day in my life that I wouldn't rather multiply by a single-digit number than divide by a 2-digit number. Somebody asks you to do 17, 2, 4, 8, 0, right, triple 0. You want to divide by 50. What I would do is I'd multiply by 1. That's 2 over 2. Because I know that 50 times 2 is 100. You have to see that. I admit that. You have to see that. And then you just move the decimal in on the bottom 2 places. And then don't even divide anymore. All I really have to do is multiply the top number by 2. A small number, 2. Then compared to dividing it by 50, multiplying by 2 is easy. 2 times 8 is 16. 2 times 4 is 8, plus 1 is 9. 2 times 2 is 4. 2 times 7 is 14, carries a 1. 2 times 1 is 2, plus 1 is 3. So the top is 3, 4, 4, 9, 6, 0, 0, 0. And since I moved the bottom decimal 2 places to the left, I have to do the same to the top. And the answer is this. You don't have to bother saying 0.00. Just like $1, $1 is the same as $1. That is 1.00 is the same as 1. 344,960, say, dollars can be written this way, or it can be written that way. Here it's kind of more clear. Oh, it's 0 pennies. No cents. Just give me dollars. Okay. I'd rather multiply by 2 than divide by 50. I'd rather just do this work here. What needs to become easy is multiplying 50 times 2 to get 100. That needs to be immediate, should be effortless. And then moving the decimal in 2 places should not be hard, should be effortless. And once it becomes that way, once you realize, oh, moving the decimal is simple, then this method will be much easier. I'd rather rather multiply by 2 than divide by 50. There's no doubt about that. I'd rather multiply by 2 than divide by 50 any day. If you have this number and you were asked to divide by 5, you can do 5 into that number. Or you can multiply by 2 over 2. Where am I getting the 2 over 2 and not 12 over 12? Well, first I'm getting 1 because this fraction is equal to itself times 1. And 2 over 2 is 1. Why am I picking that way, writing 1 and not 7 over 7? Because 5 times 2 is 10. And when I move the decimal to a more favorable place, I'm dividing by 1. 73842. Now here it is. Instead of dividing by 5, I'm multiplying by 2. 4, 8, 16, 7, 14. And then effortless. I move the decimal in one place. Just like I did in the bottom. And there is my answer. Now, I do want to comment about something. What if you can't, well, let me write it down. What if you have 143.2451 and you want to divide it by 100,000? That is, you want to move the decimal 5 places to the left. And now you're dividing by 1, which means you don't even do it. Then you have to move the decimal on the top 5 places to the left. 1, 2, 3, 4, 5. There's my decimal. If any one of those loops, and this is a loop, and this is a loop, and so is this, etc. If any of these loops do not have a digit above them, well then you best put zeros in. That is 143.2451 divided by 100,000. This is equal to 0.001432451. Okay, it equals this number. So even if you don't have enough spaces to move the decimal, yes you do. Put zeros in those loops. If somebody asks you to divide 8,004 by 20. Well, I mean, I'm just showing you the logic. This is equal to itself times 1. The way I'm going to write 1 is 5 over 5. Of course, you could have written the 5 over 5 over there. I'm just showing that a number is equal to itself times 1. A number is equal to itself times 1. Why did I pick 5 over 5? Because 2 times 5 is 1 followed by zeros. 1 0, actually. I'm just going to move the decimal in, top and bottom, and then I won't even bother dividing by the 1, which is now on the bottom. Okay, 8,004 times 5. Well, 5 times 4 is 20, carry the 2. 5 times 0 is 0, plus 2 is 2. 5 times 0 is 0, and 5 times 4 is 40. 40,020. 40020. Move the decimal in one place. If there is no decimal, it's understood to be all the way to the right. And there's the answer, 4002. 0.0. The 0.0 you don't need. The answer is 4002. And I didn't divide. I multiplied. In this case, doing the long division would not have been that bad. 2 into 8 goes 4 times. 2 into 0 goes 0 times. 2 into 0 goes 0 times. 2 into 4 goes 2 times. There's a rare case where it may have been quicker to do short division. Dividing by 2 isn't bad. I admit that. But if you said to divide by 20 instead, I definitely would have multiplied by 5, 5 over 5, would have gotten 100 on the bottom. And 100 is like dividing by 1 after you move the decimal. Okay, now, what if you have 375 over 15? There's nothing to multiply 15 by to get 10 or 100 or 1,000 or 10,000, etc. But you know what? Well, 15 is a 2-digit number. I can get it to be a 1-digit number by multiplying by 2 over 2. The bottom is 30 now, but I'll move the decimal in and it's 3. And 375 times 2, if you work it out, you'll get 750. 750, but I have to move the decimal in. That is, now you just have to do that division. And I'd rather divide by 3 than 15. Of course, I had to multiply by 2 first. I had to do this first, and now I have to do this. 3 into 7 goes 2 times. 2 times 3 is 6. Take that away from 7, 1 left over. 7 take away 6 is 1. And 3 goes into 15 5 times. And that's your answer. This mess is 25. This answer is 25. If you did the long division, a lot of students don't know the 15 table. They suffer with this. 15 times 2 is 30. That's not above 37. But 15 times 3, that's a hard problem for people. But it's more than 37. I'm just multiplying by 2 and dividing by 3. None of this 15s. Okay, it goes 2 times. You take away 30. For the record, I was done doing this by now. When you take away 30, you get 7. You bring down the 5, 75. And, a lot of students don't know the 15 table. But 15 times 5 is 75. So when you take away 75, you get 0 as the remainder, and there's the answer. Just like we got before. So instead of dividing by 15, you can double top and bottom And then move the decimals. I want that to become effortless. Moving the decimal on the 30 to make it a 3. I don't want that to be a big deal. If you move it on the bottom, you have to move it on the top. Now you're just down to that column. And for the record, you should know 3 watts give you 75 cents. Living in America, we know that 3 quarters give you 75 cents. That's 75 cents, and it's split up between 3 coins, they're quarters. Well, if you have 75 cents, and you and 2 friends, a total of 3 people, are going to share in the 75 cents or the $75, well, each one gets $25. Now, there's another thing that I want to teach you. Okay, it'll save you time. That way you don't have to run and look for your calculator. You can do these things in your head. If you have something, you have this box, for example, or you have a box, and you divide it by 2, and then you divide what you have by 3, you now have divided it by 6. That is, if you have a number, let x be some number, and you divide that number by 2, and then you divide that by 3, you really divided the number by 6. But this exercise is to show you how to go the other way. If you don't know what this number x divided by 6 is, you can first divide it by 2, and then you can divide it by 3. 2 times 3 is 6. If you have a number and you want to divide it by 12, and you're slick and you realize that 12, now this here is the same as dividing by 2 times 3. 6 is 2 times 3. You can divide by 2, and then you can divide by 3. 12 is 2 times 2 times 3. If you didn't know what 144, let's use a different number, 180. If you didn't know what 180 divided by 12 is, and most people don't. Personally, if you ask me what 180 divided by 12 is, I would think this in my head. I would say, well, 180 divided by 2 is 90. That's almost dividing 18 by 2. 18 by 2 is 9. 180 divided by 2 is 9 with a 0. Okay? 180 divided by 2 is 90. 90 divided by 2 is 45. At least I got smaller numbers. And 45 divided by 3 is 15. So I have my answer. You don't have to divide by 12. You don't have to say, oh, I don't know my 12 table, so I can't do this. No, maybe you know your 2 times table well. Maybe you know your 3 times table well. You don't even have to know your 12 times table. Somebody asked me, what is 180 divided by 15? Okay, well, there are 2 ways I would do this. You can think of 15 as 3 times 5. Well, 180 divided by 3, you can do that in your head, because it's very, very similar to 18 divided by 3. 3 times 6 is 18. That is, 18 divided by 3 is 6. So 180 divided by 3 is 60. And now you divide this by 5. And now when you're going to have to know, 5 times 12 is 60. The answer is 12. Okay, of course, I probably would have done this the way of the last topic, the last type of shortcut. I would double top and bottom. Doubling 180 is very similar to doubling 18. Double 18, add a 0. Double the bottom, you get 30. Move the decimals in one place. That is, get rid of the zeros. And 3 goes right in. 3 and 6 goes in 12 times. Same answer. Okay, when people ask me multiplication, division problems, I very seldomly do the problem that they ask me. Somebody asked me, what is 180 divided by 15? I'm telling you, I would think 360 over 30, 36 over 3, oh, 12. 12. Okay, that's exactly how I would do such a problem. It's exactly how I would do a problem like that. I hardly ever do the calculation that I'm asked to do. Why? Because I'm not that good at it. How to come up with shortcuts. For example, I suspect that most of you will not know what 128 divided by 8 is. In fact, I don't know the answer to this. I really don't. But what I do know is 8 is 2 times 2 times 2. So I do 128 divided by 2. I mean, I see it. Goes in 6 times, goes in 4 times. I see the 64. Divide 64 by 2. 3, 2. I see that in my head. 2 goes into 6 3 times. 2 goes into 4 2 times. 32 divided by 2. You should know that. It's 16. Here's the answer. 128 divided by 8 is 16. I'm telling you, I don't know that. If you asked me what 128 divided by 8 was, and you insisted that I do it that way, that is, I actually figure it out, well, if you insisted that I try to figure it out in my head without breaking down the 8, I would think, well, 8 goes into 12 one time with 4 left over, and 8 goes into 48 6 times, and 1, and next to 6, oh, 16. That's how I would do it. But nobody's going to ask me that. Nobody's going to say, do 18 into 128 this way. That is, don't break it up. I would break it up this way. I would divide 128 by 2. I get 64. That's the 2. I divide by 2 again. I get 32. And then I divide by 2 again. My last 2, and I get the answer. 8 is 2 times 2 times 2. Okay. I hope this was helpful. It definitely contains a lot of good, solid tricks and shortcuts for doing to make long division easier. And the last part was to show you how to do somewhat small numbers, division of small numbers in your head.